there. Today we're going to be looking at binomial distributions. So we will need a calculator for today. So if we have not yet gotten a calculator out, let's make sure that we try to get a graphing calculator. If there aren't enough, maybe you can just make sure to look at the person next to you, just so that when I'm here you can know how to use the graphing calculator to do these different pieces, okay? So today, again, we're going to be talking about the binomial distribution. So this binomial distribution allows us to calculate the probability that there are going to be a specific number of successful performances in a fixed number of attempts. The variable of interest is always x equals the number of successes. All right. Now, to use the binomial distribution, there are 4 different conditions. All right. The first one is that there is a fixed number of attempts. That fixed number of attempts we're going to refer to as n. Also, notice binomial, bi means 2, so there are only 2 possible outcomes for each attempt. Essentially, either a success or a failure, a yes or a no. The outcomes need to be independent of each other, and we always go assuming independence. And the probability of success must be the same for all attempts. The independence helps out with that. So each attempt would have the same probability, and we're going to call that P. Now, if the above 4 conditions are satisfied, then the probability of having k successful performances in n attempts is given by this formula. It looks a little overwhelming at first, but it's really not too bad. This just means the probability of something happen. Okay, so I'll just put a little prob there. So the probability of something specific happening is going to be equal to this nck. This basically is the number of ways, like the number of combinations of something happening. And then times p to the k. And this, excuse me, this talks about the successes. And that's what p is. P is the probability of a success raised to the power of how many successes there are. And this 1 minus p essentially is a failure, the probability of a failure. And the n minus k raises it to the number of failures that there are. So let's just practice that real quick. Assume LeBron James has the ability to make three-pointers 31.5% of the time. During the 2008 playoffs, he made exactly 18 three-pointers in 70 attempts. Calculate the probability of this occurring. Well, one thing that we need is we need the total, that fixed number of attempts. And notice that we have 70 attempts. So that is the fixed number of attempts that we can use in this problem. P is our probability, and if his ability is 31.5% of the time, we'll just kind of use that as the probability for each case. And then we need to know K. K represents the number of successes that we're going to be dealing with. And so our K is this 18 three-pointers. So if we use this formula, we're saying the probability that we have 18 successes, that's what this means. So the probability that we have 18 successes is, let's start by this nck. So that would be 70c18. So we have 70c18. Next, we go to the success part. We take the probability of a success, which was 0.315, and we raise it to how many successes there are, and that K value was 18. Next, we go to the failure part. Well, we've talked about how if the probability of a success is 0.315, what we could do is we could take 1 minus 0.315, which the formula says we should do, but we've talked before about how that's the probability of a failure. And so the probability of the failure is 0.685. And if there were 18 successes and 70 total, we can subtract 70 minus 18 to mean that there would have been 52 failures. And then that goes here. So those are the three different parts. The number of combinations, so the number of different ways that those could be combined, that you could have 18 successes out of 70 attempts. The success, 0.315 to the 18th, and then 0.685 to the 52nd. And then we just put that in the calculator. So we would have 70 C18 times 0.315 to the 18th times 0.685 to the 52nd. And we usually round again to 3 decimal places. So we look to the right, that 7 says to bump that up to a 2. So this gives us 0.062, or if you like it in percents instead, that would be 6.2%. So that is the probability of him getting exactly 18 successes in 70 attempts. Let's try it one more time. Suppose the baseball player gets a hit 26% of the time. In his rookie season, he had 52 at-bats. What is the probability that he got exactly 8 hits this season? Well, maybe we should start by explaining why it's appropriate to use the binomial distribution in this case. So let's jump to letter B first. The first thing is there needs to be a fixed number of attempts. And in this case, it said that he had 52 at-bats, so that we can use that for our fixed number of attempts. So it's appropriate because there were a fixed number of attempts that we know of in this situation. And let's just make a note that that was 52. That was our n. There were a fixed number of attempts. The second is that there are 2 outcomes for each event. And basically, when it's talking about getting a hit, you either get a hit or don't get a hit. So that works out. So we can say there are 2 outcomes. For each attempt. The success is a hit, and the failure is not a hit. Number 3. The outcomes have to be independent, so that's usually something we assume. So we assume the outcomes are independent, like we haven't been given any indication otherwise, so we assume that they're independent. Back in chapter 3, we always assumed independence. That was our HO, is that they're of that independence. And then number 4, the probability of the success is the same. And when it says that they get a hit 26% of the time, that's the probability. So we can say that the probability of getting a hit is the same. For each at-bat. And that is going to be that 0.26. So those 4 things occur, so it is appropriate for us to use a binomial distribution in this case in letter A. All right. So let's back up to letter A then, and let's look at the probability that he got exactly 8 hits this season. So we first need our N. Our N, we said, was the 52 attempts, the 52 at-bats. We need P, the probability. We said that was going to be the 26%, which we'll use as 0.26. And our K, the number of successes, this is looking at 8. So that tells us that K is 8. Now we can just put that into the formula. First we have 52C8. And now we have the successes. There were, the probability of a success was 0.26. And there were 8 of those, so I'll put 0.26 to the 8. So now let's look at the failures. 1 minus 0.26 is 0.74. And how many failures were there? Well, there were 52 attempts and 8 successes, which meant that there are 44 failures. So we would put that failure part, 0.74 to the 44th power. And then we just multiply all these together. So we have 52C8 times 0.26 to the 8th times 0.74, to the 44th, and to the nearest thousandth, that 7 bumps that 7 up to an 8. So we should end up with about 0.028, again, or if you want a percent, about 2.8%. Now, hopefully we're starting to see the 3 pieces of this formula come out, but I have good news for you. The graphing calculator has different functions that we can use, and we can use the functions on the graphing calculator in order for us to do that. Let's make a note up here, maybe in this little box, that we can use this when we have exactly K successes. Like it said in example 1, exactly 18 3-pointers, exactly 8 hits. If it's exactly K, what we can do is we can use this function in the calculator that's called binomial PDF. That stands for the binomial probability distribution frequency. And what it does is it does this for you. What we do is we hit the second key and then the vars key in the graphing calculator. And then for most of us, I believe we scroll down to choice A, which is the binomial PDF. Okay. So again, we go to second, vars, so we get this distribution menu. And there are a lot of different PDFs. It's not normal PDF, all right? It's not normal CDF. Notice there are a lot of different pieces. You have to go all the way down here to where it says Binomial PDF. And then it'll ask you to enter certain things. If you have the new operating system, like I do on this calculator, it will prompt you for those different things. But if you get a calculator that has the old operating system, it might not have that. So let me tell you the 3 things that you need to put in the calculator in case you grab one that doesn't prompt you. The first thing you're going to do is you're going to put your N value in. That's the total number of attempts. You're going to put the P value in, which is the probability. And then you're going to put the K value in. So those are the 3 things that you need to put in to the binomial PDF. Okay. All right, so let's try that in letter C. It says use the functions on the graphing calculator to find the probability that he got exactly 10 hits this season. We are still talking about this guy up here. So we know that the N is 52, the P is 0.26, and here exactly 10 means that K is 8. So that exactly 10 means that we can use the binomial PDF. So exactly 10 means we can use binomial PDF. And what we're going to do is we're going to say that n is 52, comma, p is 0.26, comma, oh gosh, sorry, k is not 8, k is 10, wow, sorry, k is 10. Alrighty. All right, so then we can put that into the calculator. So if we look back on, if we again go to second vars, notice that above the vars there's this little DISTR for different distributions. And then we can go down to choice A, the binom PDF. Make sure it says binom PDF. Then we're going to do 52. And here it prompts you for the trials. There were 52 attempts. The P is 0.26, and then the X value is 10, because that's really what we're concerned about. Then just press enter for paste, and it'll paste that right there for you, and then press enter, and then it will give you the result. So 0.072, or 7.2% would be the probability. The only really work I need to see is what you're entering in the calculator right here, and then the result should just pop up, okay? If you have a calculator that is a little older, I don't know if you can see it on this here, and you go to the second distribution, or sorry, second vars to get to the distribution here, notice that it doesn't prompt you for everything. So for something like that, you would do 52, and then you have to hit the comma, so the comma is above the 7, and then you'd hit the 0.26, comma, 10, and notice that you'll get the same result that we have here, okay? So just so you're aware in case you get a calculator like that. So this is all well and good when we have exactly, but what if we wanted to do 12 hits or less? To use the binomial PDF, we would want to find the one for 12, and then for 11, and then 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. That's a lot of computations, and to add those together. So fortunately, we have, the calculator has this thing called the CDF, which is the cumulative distribution frequency. And the cumulative distribution frequency always goes from 0. So again, this CDF is the cumulative from 0. So that means that it starts at 0 and it'll sum it all the way up to whatever number that is. Okay, so let's make a note before we get too far here that if we have something like K or less, that's when instead of binomial PDF, we're going to use binomial CDF instead, because that means that it'll cumulative from 0 all the way up to that K, which is what K or less is. So let's do that then in letter D. Again, 12 hits or less means that we would have 12 or 11 or 10 all the way down to 0. And so that tells us that we would want to use the binomial cumulative distribution frequency. So the or less tells us the CDF. So let's put our values in. And it's the same type of values we had before. The total is still 52. The probability is 0.26. And this time we want to go from 0 up to 12. So 12 is our K value. And we put that in the calculator the same way, except as this says, we scroll down to choice B. So we would hit second vars, and we go down, now notice, past the PDF to the CDF function. So make sure it says binom CDF, and then we would type the same things in. 52, enter, 0.26, enter, and then 12. And notice it pastes like it did before. And notice that it gives us the probability right away. That 5 tells us to bump that up, so we would say 0.383 or 38.3%. Okay? And that's pretty much how we use the calculator to do that. So if we say in letter E, it says find the probability that he got at most 5 hits this season. At most 5 hits means that he has 5 or 4 or 3 all the way down to 0. So at most 5 means that we want to go from 0 to 5. So that means that we wouldn't just want 1, we would want a cumulative from 0. So at most 5 means 5 all the way down to 0, so we'll use the CDF. Once again, the n value is 52. The probability is 0.26. And this time we want the cumulative from 0 to 5. So we put a 5 in this spot. And then we can just enter that in. Second bars, binomial CDF, 52.26, but this time the x value is 5. And notice that's pretty small. That 0 tells me to keep that at a 3. So I get 0.003, or that's like 0.3%. It's like pretty small. So letter F, find the probability that he got less than 20 hits this season. Well, a lot of people just start assuming, okay, less than 20 hits isn't going to be the PDF, it's going to be the CDF, but I'm going to do the 52, the 0.26, and the 20. Or are we? What does less than 20 mean? Less than 20 does not include 20, does it? Less than 20 means 19 or 18 or 17 or everything down to 0, which means that this is not going to be 20. We don't want to go from 0 to 20. Less than 20 means we only want to go 0 to 19. So what the moral of the story is, just because a number shows up in the problem, you have to think about what your possibilities are before you put it in here. The exactly that we did with the PDF, that one's always going to go there. But with the CDF, you have to see what is it that you're summing from 0 to what. Less than 20 doesn't include 20, so we would just put 19. So we'll put that in the calculator. We'll use the binomial, wrong one. We'll use the binomial CDF with 52 trials, a probability of 0.26. And this time we want to sum this cumulative from 0 to 19. And that gives us 0.967. The 0 tells us to keep that there. So that would be 0.967 or 96.7%. Okay? For time's sake, let's just jump example 3. And there's one more thing I want to talk about, and this is the idea of the expected value. When we talk about the expected value, all we have to do to find the expected value is take n times p. So anytime it says expect in a problem, that would be where we use the expected value. So let's try to do just a couple more of these together, and we'll practice the expected value also. So this says, Sophie is a dog that likes to play catch. Unfortunately, she isn't very good, and the probability that she catches the ball is only 10%. Susie, Sophie's owner, throws the ball to Sophie 20 times. Calculate the following. First, let's find the probability that Sophie catches the ball exactly 4 times. Well, exactly 4 means that we'll be able to use the PDF function in the calculator. So let's set that up. Let's use the binomial PDF function. And our total n, let's see, she threw the ball 20 times, so our n is going to be 20. Our probability is going to be this 10%. 10% as the decimal is just 0.10 or 0.1. So that's our probability is 0.10. And exactly 4 means we can put exactly 4 right here. And if we use the binomial PDF function, we'd go to second vars to binomial PDF. Now there are 20 trials, a probability of 0.10, and the x value is 4. If I go to 3 decimal places, that 7 tells me to bump the 9 up. So that 0.0897 blah, 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 really, if we round to 3 decimal places, becomes 0.090. I know we're not very comfortable putting zeros on the ends, but that really is the correct way to round to 3 decimal places. Let's look at letter B. Find the probability that Sophie catches the ball less than 6 times. Well, less than 6 is going to be a CDF because it's going to be cumulative, but less than 6 does not include 6. It's going to be 5 down to 0. So less than 6 means that we would want the CDF from 0 up to 5. So let's, for our work, say, all right, let's use the binomial CDF function. We still have 20 attempts, a probability of 0.10, and this time we wanted the cumulative from 0 through 5. Again, less than 6 does not include 6. So I would go to second vars, go to the binomial CDF, 20 trials, probability of 0.10, and I want it to sum from 0 to 5. And that 7 bumps that up, so that gives me about 0.989. All right. Next one, find the probability that Sophie catches the ball at most twice. Well, at most twice, again, isn't just one value. That'll be the CDF function. So at most twice, at most 2 times, would that include 2? It would. That would be that 2 is the most, and then down to 0. So again, we'd use the, we'd use the binomial CDF function. We still have 20 trials. The probability is 0.10. And now we want to sum from 0 all the way up to 2 to find at most twice. So we go to the CDF function. We have 20 trials. The probability is 0.10. But now we just want to go to 2. 0 to 2. And that 9 bumps that up, so I get 0.677. And then finally, letter D, how many times do you expect Sophie to catch the ball? So this expect is what a keyword that means that you're going to use that expected value. So the expected value, all we do is we take n times p. That's it. So our n here is 20. our P here is 0.1. And so we just take 20 times 0.1. And that gives us 2. And so that would be our expected value. So we would expect Sophie to catch the ball twice out of those 20 times. Okay? So that's this is the first day of the binomial distribution. I'm so sorry. I know this is so dry today. But tomorrow what we're going to be doing is looking to see what would happen if we wanted K or more values. So today we're focusing on the exactly K with the PDF, the K or less with the CDF, and then the next time we meet, we will be talking about basically K or more than K, and how we would deal with that. So please do your best and see what you can do with the topic 5, day 1, because we'll be building on that for the next time, okay? Thanks for understanding. I had to be out for an appointment today. We'll see you guys soon. Bye.